At Modzy, we focus on performance and robustness at the same time when we train our AI models. We have developed a new way of training for AI models based on backpropagation, which leads to models that still perform as accurate as any other model in the specific task they're assigned, but at the same time, they are robust and resilient against any type of white box or black box attack. We've also developed a new way of detecting poisoning instances in the training and test dataset. Our new approach acts as a filter on the data. So before any data gets to the AI model, our approach can find those bad poison instances introduced by the adversary to make sure that the data that gets to the model is as clean as expected by the user and the person who designed this AI model. We realize that our AI models are being deployed to mission-critical environments every day. As a result, we want to make sure that the AI user using our trained AI models can trust and rely on our models at deployment without any concern for adversarial attacks on the data or the model itself. We usually train an AI model to perform well in a specific task. As an example, this task can be classifying images or predicting a behavior. The training is then usually modeled as an optimization problem, where we try to minimize a cost function, which defines how well the model is performing in the specific task. So the goal of the adversary is to maximize this loss function. So the adversary's goal is to find examples that go the opposite direction. Instead of optimizing the performance desired by the model, the behavior that adversarial examples enforce on the AI model maximize loss and make sure that the decision made the model deviates from that optimal decision that the model should make. This is usually done in two different ways. We call those white box attacks and black box attacks. White box attacks rely on the assumption that the adversary knows the details about the model. This means that the adversary has some amount of knowledge on the weights, biases, and the architecture of the AI model. And then the adversary can use this information to engineer adversarial examples that will achieve that goal. Under the black box framework, the assumption is that the adversary has limited knowledge on the architecture, weights, and biases of the AI models. So as a result, the adversary should estimate the behavior of the model. This is usually done by probing the AI model. This means that the adversary sends hundreds of inputs to the model, looks at the decision made by the model according to that input data set, and then estimates the optimal behavior that the model should take, and then uses this estimation to engineer adversarial examples that can later deceive the AI model into making incorrect decisions at deployment. Under the data poisoning framework, the adversary's goal is to manipulate the decisions made by the AI model for a specific class. This is usually done by introducing poisoned data instances into the training dataset before training starts. This means that after the AI model is trained, when you look at the performance indices, you see high numbers. So you see 98% accuracy for specific classes. But at the same time, at deployment, the model makes mistakes for that specific class poisoned by the adversary.